We are in the beginning of energy transition. The whole world is progressing through reliable renewable energy. Norway is one of the leading countries in taking benefit of hydropower. However, as it has some impacts on the environment besides its limited capacity, there are no more solutions in building more of them. The solution is to find a new way. Excluding hydropower, other alternatives might be wind and solar energy, geothermal power, bioenergy, as well as tidal and wave converters. Let's look at the details of the capabilities of each one in Trondheim. At least for now, solar, geothermal, tidal and wave power may not be brilliant answers both economically and practically. Onshore and offshore wind turbines, though, seem to be more attractive. Additionally, by having a look at waste production capabilities, biomass feedstock has stable availability, so it can be counted as a reliable backup for solar and wind power. Furthermore, it can be an effective way to store biofuels including methanol, SNG and hydrogen. All, in order to achieve a constant energy, we need to have a storage system. It can be overcome by an ingenious and innovative solution. Electricity is generated by offshore and onshore wind plants. In order to have reliable constant energy, there must be a backup energy supply which is provided by a storage system, biomass system for instance. The produced syngas can take part in power generation directly in case of energy demand, or also can be used as feedstock of methanol or biomethane by applying further processes. Garden methanol plant, located just 100 kilometers far from Trondheim, can take the most advantage of this syngas to produce biofuels. This biofuel is not only a reliable backup for our supply, but also an applicable fuel in all kinds of transportation systems. Excess electricity can electrolyze water into H2 and O2. Produced hydrogen can be stored in dead wells in the Norwegian Sea and existing pipelines, and the investment can be provided through the P&A money by oil companies. Hydrogen fuel cells would be another way of power-to-gas storage. However, they are still not economical to use on a large scale as the graph shows, but the technology is still under development to make it cheaper and reasonable. Lithium-ion batteries, although an expensive option, can be used for local electricity storage in municipal locations like what we see in Mississippi. Another innovative scheme for energy storage can be presented as follows. Assume an enclosed dam like this in the sea. The inner volume of the structure can be used to store energy by pumping the inner water into the sea in case of energy surplus. In case of energy demand, though, the turbines may work to produce the stored energy. As shown by the increase in radius, capacity per cost ratio decreases. Hence, in the large scale, this may be a country or even continent-wide solution for the energy storage problem. Both financial and environmental risk assessments are crucial for this scheme. By development of technology, costs of the aforementioned energy production and storage techniques decline. This has to be considered in any proposal. The optimised scheme in case of Trondheim will be found by utilising IoT both in storing and producing energy, and performing a comprehensive economic and environmental risk assessment in the broad proposed solutions. Hopefully we are going to exploit clean energy to keep the earth clean for the greater good.